Hello class, this is a video tutorial on linear functions part 2. In this video we'll be looking at the gradient. The gradient of the line is the measure of its steepness. It is the ratio between a line's rise and run. So gradient equals rise divided by run. Just so we get a clearer understanding of this, let's say we pick any point. So let's say that this line here has a gradient of 1. That means if we pick any point here and we move across, so a run of 1, that means if we pick the next point equivalent there, that means this rise is also 1. So rise over run. Okay. Likewise, if I do it again here, if I pick any point here and I move across of 1 and I move up to meet the line, that would be 2. That means, well, this gradient here is 2 over 1, which means for every 1 run, it goes up, it rises twice. One last example to get our understanding here. 4 over 5, that means if I pick any point, move across 5 spaces, that means if I pick any point on that line after 5 spaces, there'll be a rise of 4. So rise of 4 divided by 5, rise over run of 4 over 5. Some more points that we should remember. A positive gradient means increasing linear function. A negative gradient means a decreasing linear function. So if we have a positive 3, that means when we read the gradient from left to right, the graph is going up. And likewise, if we have a gradient less than 0, for example, -1, if we read the graph from left to right, from left to right, you'll notice that the graph is decreasing as it moves along. Okay, so let's to calculate the gradient between any 2 points, let's say point A, x1, y1. These are the coordinates of the point A. They can be any numbers. And the coordinates of B, x2, y2, they can also be any number. We can calculate the gradient using this formula. y2 minus y1, all divided by x2 minus x1. So I'm going to do 3 examples for this. Hope you can follow along. Let's calculate the gradient of the following. Let's say we had a graph showing us the x and y intercept. Okay, well from here we can just merely label that this is x1, that's y1, this is x2, and that's y2. And just merely using our gradient equation, we get m equals y2 minus y1. Let's do that first. Well, y2 is 0 minus y1 of 4, all divided by x2 minus x1. Evaluating this, 0 take away 4 is -4. 2 take away 0 is 2. That means our gradient is -4 on 2, or just -2. Now, in this second example, rather than be given a graph, we just need 2 points, and that's all we've been given. Now, if you're wondering if we have to label this one x1 and this one y1, well, just to show you, we can actually let this one here be x1, y1. This would be x2, y2. So long as we don't have, for example, x1, y2. This is not allowed. Okay, so let's calculate the gradient. y2, 4, minus y1 over x2, so -2, minus x1, 6. This will give us -24 over negative 2 minus 6 is negative 8. Well, for this one, m is equal to positive 3. One last example here. Sometimes we may be given a table of values, but in this case, there's still no difference. We just recognize this as x1, y1, x2, y2. So these, reading horizontally, are the coordinate pairs. So let's calculate the gradient. M is equal to, sorry, this should be y2. y2 minus y1, so negative 3 minus negative 7, because y1 is negative 7, all over x2, negative 1 minus negative 2. This will give us negative 3 plus 7. Well, that's going to be 4. Negative 1 minus 2, so negative 1 plus 2 is just 1. Okay, so our gradient here, m is equal to 4. So I hope that gave you an insight into calculating the gradient from 3 different scenarios, but mainly just using this formula for reference. Hope to see you in the next video. Best of luck.